So I accidentally hit stop, and I didn't mean to. So now I have to have a part two, and I don't want to, so I'm cranky. All right, so here we go. I gotta just. I've got to. By the way, if any of your parents are OSHA compliant and in regulatory industries, tattle on this. This is ridiculous. Make them come give me technology that is wireless, so I don't have to die. Okay, hang on. All right. So we need to talk about the difference between heat and temperature. If you already know this, that's great. You don't need it again. You can ignore me, except that I need to talk about evaporation and the difference between evaporation and boiling. So you might want to hang out. All right, the difference between heat and temperature. Here we go. I have two highways. On one highway, actually it's the same highway, just two different times. You have two cars. Two cars. They're each going 50 miles an hour. Hopefully in the same direction. All right. Here I have highway during rush hour. And I have 10 cars. Don't tailgate, children. You like my cars? All right. On average, each of them are going 50 miles an hour. But which highway has the most energy?
The lower one.
Lower one, right? You know intuitively that energy is all about how many particles you're dealing with. So this is heat. No, wait a minute, stop. Temperature for both is the same. But heat is not. Heat for this one is 10 times more than that one. 5 times more, sorry.
Interesting.
So heat, in this instance, and this is where the analogy fails because you can't really do this, but let's pretend. Heat here would be 500. Each one going at 50 times 10. Heat here would be 100.
So now it's just the rate at which the temperature increases?
No, it has to do with how many particles are going that way.
Right, so how is this number useful to us?
Okay. So here is my beaker. It is boiling. It's almost at 100 degrees, so we're going to call it boiling. And I want you to tell me, let's see if I can do this without burning myself. I have two beakers. What's the temperature of the little beaker? 100. What's the temperature of the big beaker?
100.
100. Okay, great. Who has more heat? The big one.
Oh wait, I saw this Bill Nye episode.
The big one has more heat because there's more particles. So you could think of all of those particles as like kids at a rave. All right?
I love it.
All right. So I've got just a few kids at a rave here. Lower heat energy. 1,000 kids at a rave here. Higher heat energy. They all are jumping around making fools of themselves the exact same way. But you just got more kids doing it. More energy. Yes? You okay? So, what is heat? Heat is hello. Heat is total kinetic energy. If you like the word cumulative better, use it. Temperature is average kinetic energy. So all of this heat that this hot plate has been pouring into this beaker, That's cumulative. It doesn't always result in a change of temperature, though. Depends on if it's in a phase change or not. Cool. Bye.
So my Bill Nye outburst earlier.
Wait!
So vaporization.
Evaporation. Part 3. All right. Here is the difference between evaporation and vaporization. Okay, so
Yeah, can be.
again, so here is vaporization, right? I've got a solid, stretch these apart, making it liquid, and then break the IMFs completely, and then go choo choo choo. That's vaporization, right? Here is evaporation. I have my water molecule on top of a cup, room temperature. Water molecule on top of a cup, room temperature, right? Gas molecule comes in at really high speed. And that one goes flying off. Did it boil? Did I heat it to do that? No. It turned into a gas because it got hit with something and turned into a gas. If it comes back into contact with this, it'll recondense back into it. If it doesn't, it'll just float around the air. And that's why at room temperature, your water will eventually evaporate because the atmospheric molecules are them out.
So it's basically hitting it hard enough to increase the speed enough to change it.
It's hitting it hard enough to increase the speed enough to change its phase, but not as an entire thing. Not like that is. It's one molecule at a time. That's why it takes forever.
Oh, okay.
Yeah, that's why it takes a long time. Now, it'll evaporate quicker if this one's like much faster, right? So on a hot day, your stuff evaporates much quicker, right? Because the molecules that are hitting it are much faster.
And what was vaporization? What was vaporization?
Vaporization is boiling. Fancy word for boiling.
Okay.
Evaporation happens at room temperature or at below boiling point. Okay? Any questions? All right, you have your practice to do.